attendees may already know, but there is a YouTube channel that we maintain that it's called, I believe, Agile TV. So if you go to our website and click on this link which says Must See Agile TV, that's where all our recorded webinars are, and this one would also end up there in a day or two after the webinar has concluded. There's more information in terms of contacting us and so on toward the end of the slide deck. And if you need to get a hold of me, ashish.shankar@synergip.com. So with that, let me turn to the topic at hand. So this is part of the. So if you have followed our webinar series, we have a few sessions around the agile topic, and then we have sessions around the technical topic. But this this presentation today is actually bringing the two together. So it's not so much about good practices in agile, and it's not so much about what the technology in terms are, but essentially it's about Docker in action. And so our presenter today is Robert Bastian. He's the Director of Platform and Architecture at Drillinginfo. And so without further ado, let me hand it over to Robert. Robert, over to you.
Thank you, Ashish. Can everybody hear me okay?
Yep.
Okay, great. All right, hello everybody. As Ashish said, my name is Robert Bastian. I'm the Director of Platform and Architecture at Drillinginfo. I have over 20 years of experience in telecom, gaming, and now energy. I love building APIs and services. It's what I do, what my team does, and I also consider myself to be an Agile and DevOps advocate. So I'm here to talk today about why Docker and why Drillinginfo, decided to take the plunge on going to Docker, and what we discovered getting containers to run in production. But first, I want to give you a little bit of background on why we wanted to go in this direction. So essentially, as the Director of Platform and Architecture, I felt like my world was changing and it needed to change more. We had 5 individual teams that were building microservices in Java and Scala, and we had built a frictionless deployment of microservices using Chef and AWS that made it very, very easy for people who, once they had written their service, to actually deploy it in production on a standalone VM. And we started to have, I don't know if 25 was an explosion, but we ended up with 25 separate microservices deployed in the and each of those services is typically, but not always, deployed to a single AWS virtual machine. And then each of those services is deployed 6 times. So we deploy it once in dev, once in test, and then twice in staging and twice in production for redundancy. And so because of this, we had 25 microservices that very nearly became 150 AWS virtual machines. And so that was the real driver to move us into the onto the Docker path. And the big reason why, after talking about that last slide, was just the cost. We made it so easy to create new VMs in AWS that kind of got out of hand. Developers and teams were just spinning up AWS virtual machines without really any thought or consideration to what the cost was. And so this led to our bill, our AWS monthly bill, starting to gain visibility from senior management and even our board. And quite frankly, 6 AWS virtual machines per service really isn't sustainable within our budget, and it just almost sounds silly when you really kind of think about it. But but it wasn't just the cost. When you went and you looked at our services that were running on Amazon, you would see that nearly all of them were running at less than 1% CPU utilization, though they do burst from time to time. And nearly all of our microservices were only using 40% of the allocated memory for their JVM heap. And that was only because allocating 40% of a VM's memory to your JVM was just a standard basically that we hard-coded into each service deployment. So the net of this is, we had 150 virtual machines, and they're all essentially sitting idle. It's just a giant waste. And then once you start thinking about how much you're paying for Amazon, you kind of naturally start to say, well, maybe we could take our toys and go someplace else. Could we use our internal OpenStack platform to deploy our services, right? Or could we use an alternate cloud provider like a Rackspace or an Azure? What about the new container as a service providers like Joyent, Tudum, or even ProfitBricks? And then what about Amazon's new container service? What if we wanted to use that? How would we get there? Right? So we wanted to be portable. And so when I try to sum up the problem statement and why we needed to make a change, it was really, how can we deploy fewer virtual machines and increase the density and utilization of those machines without locking us into a specific a specific cloud provider. So do I have any questions at this point?
Yeah, so I'm seeing one question come in around essentially why you ended up having microservice for virtual machine. Was it because of configuration conflicts, or was it because the developer was simply very conservative?
It was really, I think, because the developers were conservative. And I think, when you have 1 or 2 or 3 microservices, it's really not a big deal to spin up virtual machines to run them. But as we developed more and more services, the problem became much more visible as the bill began to get higher and higher.
All right, and then our attendee is asking this question of, in your world, what does microservice really mean? Could you give an example of what's a microservice?
Sure. So, I use microservice, that's the latest buzzword. To me, it very simply means a single built-for-purpose service that has a RESTful interface. So it does one thing, and it does one thing specifically. And so we try not to blend different functional requirements or different business requirements into a single service. We break those out into very small and isolated services, hence using the term microservice.
Okay,
great. So now I want to talk about why we believe Docker can help us solve the problems that I outlined in the previous few slides. And I want to start with this slide. It's pretty famous. If you've looked at any Docker slides in the past or seen any other Docker presentations, you probably saw this slide. It's called the shipping matrix from hell. And the idea behind it is, on the left are different forms of freight, and across the bottom of the matrix, rather, are different mechanisms for transporting that freight. And what you can think about quite naturally is that each of these different kinds of freight required a different mechanism to be able to load it or to transport it on these different types of infrastructure across the bottom. So moving it from a truck to a train to a crane to a ship really depended on what you were shipping. And that was very inefficient. And this all changed with the introduction of the standard shipping container. And so this is why Docker likes this metaphor so much. Because now, with a standardized container, your infrastructure across the bottom can now standardize as well. So because the containers are the same size, they're the same shape, they have the same hooks, the same holes, the same door placement, everything's the same, now it's very easy to standardize your trucks, your trains, your cranes, and your ships on moving these containers. And so then, what's inside of this container, it doesn't matter anymore. And this is where it becomes important for us. So before the standard shipping container became part of our international shipping industry, right, there was actually people whose responsibility it was on boats to make sure that certain freight wasn't placed next to certain other types of freight. The example I like to use is you can't put the monkeys next to the bananas because the monkeys will eat all your bananas. But if your monkeys are in a crate or in a shipping container and your bananas in another shipping container, it really doesn't matter if they're right next to each other or sitting on top of one another. Those two pieces of freight are isolated. And that's why this is such an important metaphor for us here at Drilling and for Docker. So if we kind of go back a little bit and we talk about why it was important, what we looked like before we started to use containers, we had a very inefficient use of memory and CPU resources. So on this slide here, each gray box represents a virtual machine, while each of the colored shapes represents one of our microservices. And so you can see each one is deployed to a standalone virtual machine. We deploy multiple virtual machines so we can have high availability and redundancy. But as I mentioned, this is extremely inefficient use of our memory and CPU resources. And so now, after containers, each of these microservices, each of these shapes is now isolated in a container, and now we can deploy many more of them safely to a virtual machine than we could in the past. And now we're making use of the resources we've purchased from Amazon much more efficiently. So just to sum this up here, why is Docker important to us? Why I believe it's important is it enabled us to increase the density and isolation of microservices per virtual machine. So where previously we're at 1-to-1 or 2-to-1 on services per virtual machine, now we're at 9-to-1. And we don't actually know where the limit is yet. We're still kind of feeling our way there. But 9-to-1 is making a huge difference on the number of machines that we have to provision. Each of these containerized microservices are portable across all of our machines and providers. So the same container that I can develop with on my little Mac laptop here is the same container that I can deploy on OpenStack. It's the same container I can deploy on in our data center, and it's the same container I can deploy in Amazon or Rackspace or Azure. And lastly, starting a container is so much faster than starting a virtual machine. For those of you who have had some experience using Vagrant or other tools to provision virtual machines, you know the pain of waiting for those virtual machines to come up. Containers are much, much faster, and it's so much easier to develop with. Ashish, do we have any other questions?
Yeah, actually, a couple. So one question is that did he actually have to take away developers' ability to spin up new virtual machines? How do you sort of make sure that developers don't spin up new machines despite this architecture in place?
It's a great question, and the answer is yeah, we did. When we started here, all developers had access to AWS, and all developers had an easy push-button way to spin up a virtual machine, and that really had to stop. And so we actually put, our DevOps organization kind of in between the developer and AWS, and we said, going forward, in the ones who are going to make the decisions on whether or not we need new virtual machines. And so what we did for our developers was our IT department provisioned an OpenStack cluster for them so that they can spin up virtual machines as much as they want. Any other questions, Ashish? Can you guys still hear me? Hello?
Can you hear me now?
Yes.
All right, good. So, other question was with respect to this last point you made, is containerized microservices much faster. The question is, why is it faster? And if you could also talk about the order of magnitude, is it 3 minutes versus 4 minutes, or is it 3 minutes versus 3 seconds?
I think the order of magnitude is essentially 10x, right? So if you're starting a virtual machine from scratch, at least on my laptop, and you're starting a container of the same service on my laptop, I mean, I haven't timed it, but I'll tell you it's probably 3 seconds to 3 minutes, if that. The containers start up lightning fast, and so I think you guys should check it out for yourselves and see, maybe your machines, provision Vagrant virtual machines much faster than mine, but for me, it's no contest.
All right. And just one more question, I guess, is around clusters. So in your world, do you actually end up having deploy, these microservices deployed as clusters, or are they largely just, two instances sort of acting as backup for each other?
So it's actually the latter. I'm going to talk a little bit about clustering at the end of my presentation, but right now we're actually deploying our containers in a redundant to 2 different virtual machines with a load balancer in front of them.
All right. So that's all from my side.
Okay, great. All right. So we've talked about Docker, talked about how much it can give us and how much it has given us. But what we didn't know was what really took us a long time to build, and that is that starting a container with Nginx in it, which is the standard example you'll probably see on the net, is trivial, right? But starting Nginx with a configurable environment is not trivial. Right? So doing dynamic configuration of a container across different environments based on different configuration is hard. And so what we ended up with is we really needed what I call a platform to actually deploy microservices in production. So, and we needed the following, right? We needed to build and push Docker images to an image repository, right? We needed the ability to pull the image down from the repository, start it up, and configure it. And we had to determine where this container was going to run on which virtual machine. Right? Then our applications had to discover these containers and bind to them so they could actually make use of them. And then our containers also became dependent on other containers, so we had the same problem where the containers now needed to figure out how to discover and bind to other containers. And then at the end, how do we even operate and kind of manage all of these servers, in containers? How do we manage this new infrastructure that we're building? So let's go through each of these, and we'll talk about them in a little bit of detail. So the first problem we had was, how do we detect changes in GitHub and build a new Docker image? And then where do we store our Docker images? So for the first one, it's pretty standard. We use Jenkins. So right, Jenkins is listening for changes in, I guess Jenkins is receiving notifications from GitHub. When Jenkins receives that notification, it's going to build our new image. And when it's done building it, it pushes it up to Dockerhub. So let's talk about this in a little more detail. So all of our images, you have to have a base image, right? And so the base image we started with was Ubuntu 14.04 image that we use for all of our virtual machines. However, we quickly found out that building our services with an Ubuntu base image ended up making our images about 1 gig in size. And 1 gig is a lot to be pushing and pulling back and forth between Dockerhub. So we did some investigation, and we found a Linux micro distribution called Alpine that was much, much smaller. It was 5 megabytes of it in its distribution than Ubuntu. And so now our typical microservices are a little bit under 400 megs, which is still not great, and we want to improve that, but it's much better than 1 gigabyte. And so we store these images at Dockerhub. We did try the Docker Trusted Registry and Core OS Enterprise Registry, but frankly, I feel like the Docker Trusted Registry was too expensive for what it actually provided, and that the Core OS Enterprise Registry didn't give us any performance increase over pushing to Dockerhub. And then I just want to mention here that we use tags on our images, right? So as part of our continuous integration environment where every commit builds a new image, we tag those images as latest. And those are the images that get deployed to our development environments and our integration environments. When an image or when a service is ready for release, we tag it using the semver nomenclature, which is the major, minor, sub-minor nomenclature. And that allows us to actually deploy specific version images into our staging production environments. And so then, the next problem is, now that we have our images at Dockerhub, which host do these containers run on? And then, how are we going to even start the container with the configuration from the environment that it's in? And so for both of these problems, we settled on using Chef. Maybe settled on isn't the right word, but we were a Chef shop, and so we decided that we were going to use the tooling we knew and we understood for solving this problem. So Chef schedules containers on specific hosts using Chef roles. So this is an extremely dumb form of scheduling, right? We are actually specifically saying, I want to run container X on this node. I want to run container Y on this node. So in our run list in our roles, we are listing out specifically which containers we want to run there. And then Chef provisions and configures those containers using Chef recipes and environments. So what happens is that each microservice has an associated Chef recipe specific for it that converts attributes from our Chef environments into container environment variables and sets those environment variables on the Docker run command that then Chef executes. So Chef actually starts the container and provides it with all the configuration it needs based on the current environment that this container is running.
So Robert, if you don't mind, I'd want to sort of interject with one or two questions. There is this question around, in your implementation, are you basically doing one microservice per container, or are there many microservices within the container, and do they sort of share a class loader? Or so if you could speak a little bit to that.
Sure. So one of the things we tried to do was we tried to kind of go with the one process per container. So each microservice runs in its own container, and at a dynamic runtime, there is no sharing between the containers. We do have frameworks and libraries that we've built that our microservices share at build time, but there's no sharing at runtime.
All right. And then there's another question around how do when new containers sort of come online, how do they get discovered so they get assigned to the right load balance and so on? And it's possible you probably covered this much later, but if you think you can address this quickly now, that'll be great.
Well, it's actually perfect. It's my very next slide. So, so the person on the phone, on the conference call asked, "What about service discovery?" Right. So the problem is, how can our browser-based applications discover and bind to these containers? Right. Service discovery is something that we kind of broke into two parts. Right. We break it into the service directory, and then we break it into the service discovery part. So let's talk about the service directory first. So the first part of this is console, right? So console is a tool from a company called HashiCorp, and it acts as our service directory. And so what happens is that our containers automatically register themselves with console when they start. And one thing that I want to bring up here that's really important and really interesting about Docker is that the Docker daemon emits real-time lifecycle events, right? So if your container starts, it stops, it crashes, the Docker daemon notices this and emits events, and you can subscribe to those events and take actions on them. And so that's what we're doing here, right? There's a utility container by another group of folks from Glider Labs. It's called Registrator, simply enough. And Registrator listens to these events from the Docker daemon, and when it receives a start event on a container, it then registers this as a service within console. And in addition to that, which is really important, is it not only registers the service in console, but it also registers it with a health check, right? So console now knows about your service, and console knows whether your service is healthy or unhealthy. So very, very key point. And then that takes us to the next part of this, which is service discovery, which is more specifically, how can the browser then figure out how to get to console, how to get to these services? And for that, we have a two-part solution. And that is that we use another tool called console template, and we use Varnish. So Varnish is our load balancer, and console template is what's telling Varnish about the location of containers. So console template participates in the console cluster, joins it as a client. And console template is monitoring for services in console. And when it finds those services, it actually updates our Varnish configuration files and creates backends for our services. And it can also automatically take them out if they're sick. So console template is polling every 5 seconds. It's polling our console cluster. When it discovers a new service, it adds it to Varnish. When a service goes sick, it removes it from Varnish. And then our browser application use routes we provision in Varnish to reach our services running in containers. Any questions, Ashish, on this?
Looks like we have satisfied most all the questions so far. So I would certainly encourage attendees to post more questions, and we'll just take care of them as they show up on the chat channel.
Okay, great. So then that takes us to our next problem, which was, okay, we have microservices now that depend on other microservices, almost like a mesh, right? So how then do our containers discover and bind to other containers? And for this, we went with a very similar solution, but instead of Varnish, we used Nginx. And so what happens here is almost the same thing, and that console template is subscribed to the console cluster. It's looking for changes in our services. And when it finds changes, it basically updates an Nginx comp file and then restarts Nginx as necessary. Now, one interesting thing to talk about here is that originally we tried to solve this problem with Docker's links. So we would link one container to another container that has that it needed as a dependency. But with the current state of Docker, this led to some interesting, well, I don't know if interesting is the right word, but led to some perhaps anti-patterns. One was that we had to deploy a container that was dependent to every host, right? Because Docker links didn't work across hosts. They only worked within a single host. And then the other thing we discovered was that Docker links couldn't survive container restarts of the dependency, right? So if the dependent container was restarted because of version change, any container that was dependent on it suddenly had stale links to the container, and then that container itself needed to be restarted. So in the short term, we did a lot of crazy work in Chef to restart all of the containers in the dependency tree. And then all of that went away when we went with this method of using Nginx as kind of our DNS way of reaching our containers. And so now we have our browsers can find and bind to our containers can find and bind to our containers. We've talked about how Chef can deploy our containers and manage our containers. But how do we detect failed or failing containers now? How do we operate on our containers? And for this, we ended up using a tool called Uptime, which is a Node.js application. It's open source and freely available for anybody to use. And then we forward those events from Uptime to VictorOps for alerting and for escalations. So Uptime is being notified of Docker containers and monitoring them almost the exact same way we use the registrator to register our containers with console. So when the container starts, and I mentioned before that lifecycle event is emitted, we created our own custom program based on Registrator that then takes that container lifecycle event and turns it into a monitor and uptime. So as soon as the container starts, this tool will register it with uptime, so uptime will start monitoring it. And then if uptime detects that that container is down, then it will notify Victor Ops, and then Victor Ops will send out emails, text messages, and pages to our production support staff to take action. And so lastly, a problem is how do we monitor and manage the usage of hosts in containers? And for this, we're using a SaaS platform called Datadog. Highly recommend you guys check it out. Datadog helps us visualize the resource usage on a host. Datadog has custom Docker parameters and attributes that you can visualize and graph. So it helps us understand how our services are performing, helps us understand how to monitor our applications inside the container, right? And it also helps us understand how to pack the containers on the hosts by letting us know, what is the current utilization on the host, what is the current memory availability on the host. So this is how we can tell how many more containers that we can really fit onto each host. And so to sum it all up, at the top left, we have GitHub, and then we have this path, right? And the GitHub notifies Jenkins, which builds the image and pushes it to Dockerhub. We have Chef that is monitoring Dockerhub for increments for new versions of the image or new versions or new tagged versions of the image, and it deploys those to our platform. Once it's deployed to the platform, our containers automatically register themselves with console and uptime, and then our console template then automatically updates our varnish cache so that our browser applications can find our containers. And so just to kind of sum up this portion of my presentation, Docker has enabled us to reduce our cost for our infrastructure hosting, right? We're wasting a lot less of our virtual machine resources. We're making use of the memory we've actually purchased on each virtual machine. It's enabled us to have a standardized deployment mechanism for our microservices across any kind of environment now. We now have a standardized service directory and service discovery mechanisms and standardized metrics dashboards, monitoring, and alerting on this platform.
So, Robert, let me interrupt you for a minute here. I think there are a couple of questions around. So you've sort of identified what problems you had. You've went down a particular path, and you got a containerized sort of architecture in place. So the questions are more around. Give us a sense of what sort of effort, time, people involvement was required for you to successfully arrive where you're at right now. And then the other question is more around sort of ROI. Cost saving is one thing, but what did you have to put in to get to that cost and cost saving, and so what's sort of the return on investment?
Sure. So I can answer both questions pretty much at the same time, which is that it took us to do this. I would say we've had 2 engineers pretty much working on this, one of them full-time, one of them part-time, and myself. And I think we started this effort back in April of this year, and I believe we deployed our first container to production in either late August or early September of this year. And since then, I think we now have 15 or 16 of our services now deployed and running as containers in production. In terms of return on investment, we've probably spent more on building the platform. I don't have the exact numbers. In building the platform and adding the new hosts for console, adding the new hosts to host our machines, adding new hosts to host our containers, then we've actually saved in reducing the number of virtual machines that we've taken offline so far. But where I think this is actually going to work out for us in the long run is now we have more of a platform to deploy the microservices that we're going to develop in the future without increasing our spend on virtual machines on a per service basis. So, as new services are written by developers, they are going to be deployed to this Docker platform. And so the marker that we've put down here is that going forward, all services must be deployed in the container. We're not going to provision virtual machines on a per service basis anymore unless there's some real different reason for us to do so.
Okay.
All right. So, that takes us to this slide, which is, Chef has gotten us to where we are today. And as I mentioned, we're a Chef shop, and so we have a lot of Chef experience. But it's not where we want to be. Specifically, container orchestration is not ideal, and host provisioning and pooling is also not ideal with Chef. And so for orchestration, what we want to do in our roadmap, right, is we want to use Docker Compose to replace Chef roles. That will define the microservices that are deployed on our micro-platform, or really any container at all, and on which Docker host they run on. So Docker Compose, for those of you that don't know, it's a tool from Docker, and it has a YAML file, and that YAML file defines which containers run, right? And right now, you can standalone, you can run the Docker Compose on a single host, right? So you can also then define the environment variables for each container within this file. So this Docker Compose YAML file along with Docker Compose could replace Chef as our kind of scheduler and provisioner of containers. And I think the key part I want to stress is that, and I think you can already see this happening, is that the infrastructure as a service providers are going to standardize on Docker Compose for container orchestration. A lot of them today, including Amazon and others like Stack Engine, they have their own kind of proprietary orchestration language. But at the last Docker convention, at DockerCon, Amazon did announce that they're going to support Docker Compose going forward. And I think all of them are going to go in this way. And so now not only will your container, your single purpose container be portable across providers, but I think your orchestration of your containers, your whole platform based on Compose will also be portable across these providers. And then that takes us to provisioning and pooling, right? So Docker Machine is another tool from Docker, which I think will replace Chef virtual machines. And then Docker Swarm, which is yet another part of the Docker ecosystem, is going to replace Chef for scheduling our containers on a host. So as I mentioned earlier, right, we're doing really dumb scheduling, right? So we're annotating specifically which containers are going to run on which host. But Docker Swarm will enable us to take all these Docker machines that we provision, these virtual machines, and pull them into a single kind of single pool of compute and memory resources. And then we can take Docker Compose and we can run our Docker Compose on our Docker Swarm. And then Swarm will provide the scheduling to determine which container runs on which virtual machine in that pool of compute resources, compute and memory resources. Okay. That is the end of my presentation. Is there any questions I can answer at this time?
So, Robert, maybe you may have to mute your audio or something while the question is being asked, because a lot of people reported echo on the line.
Okay.
So try that. So anyways, so the questions are more around this topic of buy-in and so on. So as you mentioned in the beginning of your presentation, there was visibility at the board level in terms of AWS costs and so on, and clearly that's a great tailwind. But as you were implementing, did you actually have to obtain buy-in from the application development teams to roll out their application as microservices, and then B, did they have to do any sort of conditioning in order to fit well within the containerized architecture?
Okay, so absolutely I had to get buy-in from the developers, right? So, I've been talking about Docker and keeping the application development teams up to date on what we've been doing with Docker and what we've been building as a platform team. And so a lot of them were very excited by the technology and were willing to jump on board and make use of it. At the same time, though, from a coercive perspective, I said, look, at this point in time, I think our Docker platform is solid. It's running well. It's been proven out with the platform services that were already running there. And so going forward, I need buy-in from our DevOps team and from our application development teams that everything going forward is going to be deployed on the container, specifically for the purposes that I outlined in this presentation, which is to save money and also provide a standard mechanism for how we're going to operate these. And so the simple answer is it took both, right? I had to get buy-in, I had to sell it, but at the end of the day, we still had to have gates and processes in place to make sure that this is actually used and actually followed.
All right, and then a few more questions, and I'm really happy that the questions are pouring in. So I'm gonna try covering them as quickly as possible. So another question is around were there any competing technologies you looked at other than Docker? I know CoreOS has an emerging containerization software called Rocket, or there might be others you may have looked at before adopting Docker.
Sure. So, the short answer is not really. With regards to Docker and with regards to Rocket, I think you're going to see that, the Rocket specification was something that, Docker is going to contribute to, but Docker is still the 1,000-pound gorilla in the room in the same way that Microsoft was the 1,000-pound gorilla before, in terms of, someone who broke into a space as a corporation and kind of dominated it. Now, there was another reason, though, why we didn't really spend a lot of time looking at some other tools. Some people might want to know why did you build this platform, on your own and from scratch? Why didn't you just use Mesos, or why didn't you just use CoreOS, or why didn't you just use Kubernetes? And the reason for that is it was important to our team for us to really understand the problems that we were trying to solve. And so by going through the mechanism that we did and encountering these problems, almost one-on-one, we'd take a step and we'd find a problem, we'd have to solve it. We really learned a lot about, using Docker and about how these things, how these problems had to be solved. And I think had we picked a large tool like a Kubernetes or a Mesosphere, we'd have bought a lot more product than we probably needed to solve our problems, and we probably would have had a lot more confusion around how to use those tools. So we used the tools we had, we solved the problems that we came across, and by going through that, now we feel like we have a really good idea of where we want to go in the short and mid-term with this platform.
All right, and then another question is, it looks like that you have to sort of experiment with a lot of things and sort of figure out what works in your environment and in your context before we kind of finalized on these various moving parts. So the question was more around, were there any any enabling factors by way of organization or culture and environment that help you through this evolution process? And was there at any point, when the containers weren't out yet and you were still in the process of building the solution, were there headwinds around or impatience around what you were doing?
So I'm going to say no. There weren't any headwinds. Wasn't really any organizational impatience, I don't think, around what we were doing. I will say a couple of things, though. It can be hard to judge that, right? I mean, we were working on Docker for a very long time. People might have started to think that it was a unicorn or that it wasn't going to work. I think, we demonstrated to the organization enough, and we did enough kind of checkpointing that people understood that we were making progress. Now, what I will say is that, I got frustrated during this process of wondering when these problems were going to stop, when we were going to stop discovering the next hurdle we had to get over. But I think that kind of goes to, the way that we like to do our development, which is we consider development to be a learning process. Right? We don't see this as Microsoft PowerPoint, you estimate and then you do and you get it done on the time that you said you were going to do. Right? All the stuff that we had to do this had never been done before by the people on this team. So everybody was aware that there was going to be a lot of learning and a lot of experimentation that was going to be a part of this development effort. But the benefit we get is the learning and the experimentation. So we got a lot out of doing it that way. And so that's the way we've taken on a lot of our work here, is understanding that it's through the doing, it's through the learning that we're actually going to do what we need to get done.
All right. And another question is more around when developers are doing their work, at what point do they sort of enter into the containerized world? So are they essentially doing development in a container on their machine, and then that container is what essentially gets deployed and moved around in various environments, or are they is there a sort of a gateway or checkpoint where they start putting stuff into containers?
Sure. So right now it's more about it's more something that happens at deploy time, right? So the developer will write their service, locally, and then it comes time for them to deploy it to our integration environments or staging and production environments. And at that point, that is the point where they have to tie in to the platform. So they start building their image and they figure out how to get that image provisioned and deployed. But I don't think that's ideal, right? I know from myself and my own development that I'm doing, I'm finding myself developing in containers now and actually working more in containers day to day. And I think the benefit of doing that is going to be that if I, am working on my container and now I'm testing my program inside the container, I have a much greater sense of security that this is exactly how it's going to be when it gets deployed to the platform and whatever infrastructure that platform is.
All right. And so the next question is more around, all told, how many developers is this platform serving on a day-to-day basis? And I guess it's more of engineers, I guess, or developers, QA, DevOps folks. Could you sort of give us a sense of that?
Sure. So I think between between all the engineering teams, the QA organization, DevOps, I think we're probably between 50 and 60 engineers. Not all of them are working containers yet. It's still something that we're pushing out to each group as they write new services. We're not forcing them to go back and revamp existing services to deploy them in containers. We're only trying to make them work in a container and deploy in a container going forward.
All right. So our next question is around Varnish. So when you're using Varnish for load balancing, did you actually have to put an absolute path there to do the load balancing, or were you able to implement sort of relative paths? And I guess the follow-up question to that is, does the web browser application need to do anything different, either, say, for example, being a single-page application or something, in order to be able to leverage Varnish?
We use absolute pathing in Varnish. Dynamic pathing in Varnish is very difficult. It's not as easy as it is in another tool like Nginx, but then Nginx doesn't have the great caching that Varnish provides. And then the answer to the second question is no, we didn't. The applications are still hitting the same endpoints on Varnish that they always hit. It's just now that those endpoints, instead of relaying that service request to a virtual machine, now relay it to a container. So there was no change there.
All right, so I know we have a few more minutes, so I'll allow our audience to post more questions. So in the meantime, if you could just, I guess, move the slides forward. I just wanted to cover the next upcoming webinar, and so I guess that's my contact information. Let's move on. So our next webinar is on the topic of role of architect in Agile, and this is again a very interesting conversation because within the development community there are sort of competing points of view around whether we really need a dedicated person called architect, or is architecture an evolving picture based on what developers do. So it's a very good topic, and Chris Edwards is presenting, and I encourage everybody to visit us on our website and register. And then this session is on 12th of November, so next week, or next month. A few more questions that have come in. The question is, can you fit bits and pieces of different load balancers with the other stacks that you mentioned? So, Robert, I don't know if you have a...
Yes, I'm sorry. So I'm not sure I understand the question, but I think the answer is yes. We didn't have to use Varnish. You could use Nginx, you could use Apache, and that's the nice thing about console template, right? This console template allows you to dynamically update the configuration files of whatever load balancer you want to use. So one I didn't mention, which is very popular, is HA proxy. And so console template works with HA proxy in the same way. And so you can make use of any of those in this type of platform.
All right. So let's give it a few more minutes for people to ask any other remaining questions. So maybe we can quickly cover a few points about Synerzip. So we are, if you go to slide 40, Robert. So a lot of people on this call probably already know about Synerzip, and the best way to stop me going through this slide is to ask a question about the presentation. But so very quickly, Synerzip is a trusted software development partner for a wide variety of companies. Typically, we focus on small and mid-sized technology companies that are looking to accelerate product development in their growth phase. And one of the essentially the value we bring to the table is bringing in very high caliber software professionals to the team. We are big believers in Agile, and as a result, we can really mitigate risk around delivery and so on. And then because of our ability to execute this with offshore economics, the the cost economics are already baked in our model. So I encourage our audience to check us out. One of the questions, Robert, that's just come in is, do you have any plans for joint?
So that's actually a great question. So for those of you that don't know about Joint, Joint has a really interesting offering. It's called Triton, and it allows you to run containers on bare metal without having to provision a virtual machine. In Joint, these guys are old Solaris guys, and so they have this, I don't know if it's a hybrid Solaris platform or how exactly they do it, but it would, from my perspective, remove the need to even know about a virtual machine at all. And they would just essentially provide us resources, and we would deploy a container, and we would pay them by the container instead of the way we pay Amazon for a virtual machine today. And so, yes, I mean, we're interested in Joint. We've talked about internally, and we've talked with Joint about doing a prototype, and we hope to actually do that at some point, either in Q1 or Q2 of next year.
All right. And then I know there's a question about, are these slides available for download? And the answer to that is yes. We typically take a day or two to do some post-processing, but a link will post on Synergis website, and be sure to kind of visit us in a couple of days. Robert, another question for you is, how close are you to having all your services running in Docker? So the question is every virtual machine now a Docker host?
Okay, so the answer, I'll take the last one first, which is no. Every virtual machine is not a Docker host as of yet. We have reduced the number of virtual machines we deployed for services, for specifically these microservices, almost by 50% in the last month to 6 weeks. And also now that we have the platform, we won't be increasing it. However, we probably won't ever get rid of all of them. Some of them are legacy services that, I just don't think that there's the ROI on converting into containers. And so those will probably just let them live out their lifestyle, their lifetime on a virtual machine until their product is deprecated, in which case then we'll just shut down the VM.
All right. So we have a couple of more minutes. If there are any quick questions, we're happy to take them. But I think we've pretty much run out of questions as well as our time. So I wanted to take a minute to thank you, Robert, for sharing this with us. This is Docker in real action, and it's very interesting, at least to me, to see how the technologies and features and so on that we are often buried in, that kind of comes to real world situation, and it also gives us a glimpse of why this idea of containerization is really taken off across in the IT landscape. So Robert, thanks a lot for your time and putting these slides together for us.
Thank you. It's much.
All right. So with that, I would close this the webinar session today, and please keep an eye out for the recording link to post on Synergis website. And while you're there, do register for the next session around which we'll talk about architecture in Agile. Thanks a lot, and everybody have a good one. Bye-bye.